you are, and this video will be about localization of function in the brain. Quite a hard topic, but if you just stick with it and focus, it'll be fine. So localization of function refers to the principle that different functions of the brain, such as language, memory, hearing, they all occur in different locations of the brain. In the early 19th century is when interest to understand localization really started taking place. Franz Gall's theory of phrenology, which is the study of the structure of the brain to determine character and capacity, was undoubtedly influential but was quickly discredited. Shortly after, a French man, I assume, called Pierre Fleuron was using animal experimentation to determine that different parts of the brain were in fact responsible for different functions. Since Gall's and Fleuron's day, techniques that we have used have become considerably more sophisticated, as has our understanding of brain localization. Before we move on, we have to understand that the brain has four main divisions, which is the frontal lobe, the occipital lobe, temporal lobe, and parietal lobe. Here is one that I made earlier. Already we can say that these different parts of the brain have different functions. The frontal lobe is mainly for reasoning, rationality, thoughts and emotion. The occipital lobe is mainly for vision. Temporal lobe is associated with language, and the parietal lobe is associated with sensory information and cognition. And before we move on to the next bit, we also need to understand something that will be in another video. Lateralization is the idea that the brain has two hemispheres, so it's split into the left and right hemisphere. That's the basic thing that you need to know right now. We're going to focus on two other parts of the brain. So first is Broca's area, which is found in the left hemisphere of the frontal lobe, and this is associated with speech production. And next is Wernicke's area, which is an area of the temporal lobe which encircles the auditory cortex, and this is associated with understanding language, so processing language. Broca's area is named after the French neurosurgeon Paul Broca. He operated on a patient that he called Tan because that was the only syllable he could pronounce. And Tan had an unusual disorder. Although Tan could understand language, he couldn't speak or express it in writing. Broca also studied 8 other patients, all of which had similar language deficits and also with lesions in their left hemisphere. But patients with damage in these areas in the right hemisphere didn't have the same problems, and this led Broca to identify the existence of a language centre, the posterior portion of the frontal lobe of the left hemisphere. This area is believed to be critical for speech production. However, neuroscientists have found evidence of activity in Broca's area even when people did activities that had nothing to do with producing language. And additionally, Fedorenko et al. In 2012 found 2 different parts of Broca's area, one for producing language and another for cognitive tasks, which shows that maybe Broca didn't have complete understanding of his own finding. This study supports the idea of localization of function because the patients with language deficits all had problems in the same part of the brain. This suggests that there is a part of the brain specifically for language production. Shortly after Broca discovered Broca's area, Carl Wernicke, a German neurologist, discovered Wernicke's area. This was located in the posterior portion of the left temporal lobe. Whereas patients with a lesion in the Broca's area could understand language but not speak, patients with a lesion in the Wernicke's area could speak but not process language. Wernicke proposed that language involves separate motor and sensory regions located in different cortical regions. The motor region, which is in Broca's area, is close to the area that controls the mouth, the tongue and the vocal cords, so this is obviously essential for speech production. The sensory region, which is located in Wernicke's area, is close to regions of the brain which are responsible for visual and auditory input. Input to these regions are transferred to the Wernicke's area, where they are recognised as language and given meaning. So there is a neural loop running through Wernicke's area and Broca's area. On one end is Broca's area, which is responsible for producing language, and on the other end is Wernicke's area, which is responsible for processing language. And again, this shows that different parts of the brain are responsible for different functions. You can use here the case study of Phineas Gage, a 25-year-old railroad worker. He was preparing to blast some rocks using explosives, but he dropped his tamping iron onto the rock, and in doing this, it exploded. The explosion hurled the meter-length iron pole point first into his left cheek. It passed behind his left eye and exited his skull and his brain He survived and his brain recovered, which is another thing called brain plasticity, which is when the brain recovers from trauma. But the thing was that Phineas Gage's personality had completely changed. To his family and friends, he wasn't the same person. This was because the pole had lacerated his frontal lobe. The frontal lobe is responsible for emotions, rationality, feelings. A lesion in the frontal lobe can lead to personality change. However, we can evaluate this and say, because it's a case study, we can't really generalise it to every situation, as not everyone's brain recovers at the same rate or acts in the same way. Also, it doesn't really take into account any of the factors that could have affected his personality and mood. For example, after such a traumatic accident, you would expect that someone would get headaches or migraines, which obviously will put someone in a bad mood. It may not have just been down to the actual accident. And there's a problem with ethical issues. Confidentiality wasn't maintained, and he should have had the right to remain anonymous. So how can we evaluate brain localization? First, there's a wealth of evidence to support brain localization. This comes from brain scan evidence. Peterson et al. In 1988 used brain scans to show that the Wernicke's area was active when participants listened to something, and the Broca's area was active when participants read something. And Tulving et al. In 1994 revealed that episodic and semantic memories occur in different parts of the prefrontal cortex, which again shows that different parts of the brain have different functions. The second evaluation point is that there's also neurosurgical evidence. Surgically removing or destroying parts of the brain to control behaviour developed around in the 1950s. Walter Freeman developed lobotomy, which was a brutal way to sever connections in the frontal lobe to control aggressive behaviour. Doherty et al. In 2002 studied 44 OCD patients who had undergone a cingulotomy. This is lesioning of the cingulate gyrus. A third of the participants met the criteria for a successful response, but only 14% met for a partial response. Success of such procedures highly supports brain localization. However, there's also evidence that goes against brain localization. Carl Lashley in 1950 said that brain functions aren't localized. He used animals to study this. So Lashley removed parts of the cortex in rats, up to 10 to 50%, when they were learning a maze. He found that removing these parts didn't really have any impact on the rat's ability to learn the maze. So this suggests that learning is too complex to be localized and requires involvement from all parts of the brain. However, a big drawback of this study is anthropomorphism, and we can't generalize animal studies to humans. And the fourth evaluation point is plasticity. So plasticity, as I've mentioned before, is a brain's ability to recover from trauma. So there are several cases of stroke victims who have been able to recover the parts of the brain that were supposedly damaged from the stroke. So they were able to recover these abilities as a result of a lot of different parts of the brain coming together to make up for it. And this supports a holistic theory rather than brain localization, as many different parts are involved in the one function. So that's the end of this video, and it's a lot of technical stuff, but if you just keep going over it, keep revising it, it actually starts to make sense. So I hope it was useful. As usual, like, subscribe, comment, because it makes me really happy. And yeah, have a great day.